Now let us see part B, that is the experimental instrumentation detail. For both the experiments like the absorption coefficient in radioactivity as well as that of the counting statistics. The instrumental part remains the same in both, and that refers to the measuring instrument, that is the detector Geiger-Müller counter. Now in these two experiments you have used GM counter as a detector. You should actually know that how does the detector perform and what is the detail of the schematic of the GM tube. So in brief, you can consider this to be GM tube is an ionization based gas field detector, and this is a cylindrical metallic tube closed on one side by mica sheet or Melinex foil. The Melinex foil is a polymeric foil which is transparent to the radiation. The other end is fitted with an anode made up of tungsten wire. The anode is inserted in a particular closed disc or a flange. Now let us understand what is the working principle of GM tube. The anode is connected to the power supply which provides DC voltage and which can be varied from 0 to about 1800 volts positive. Now the outer cylinder is connected to ground and the inner one becomes the anode. So there is an electric field between the cylindrical cathode and the central anode wire. Now when the radiations, that is the beta particles, enter through the mica or Melinex window, they ionize the gas. Now here the gas is argon which is filled in an evacuated this cylinder. Now argon is a monoatomic gas and which can get ionized when the radiations of sufficient energy are incident on it. Now the beta particles enter into the tube and they ionize the argon gas and generate electrons and positive ions. Now naturally the electrons will move towards the anode, which is central anode, and there is a symmetrical geometry for the central anode. So the electrons will move towards the central anode, that is the anode wire, wherein the positive ions will be spread up uniformly towards the cathode, cylindrical cathode. The electrons are attracted towards the positive anode, and because of that they form the signal. Now the signal is formed when these electron charge get collected and flow through the resistance, and they form the signal because there is an RC input circuit combination, and this signal is first amplified by a linear amplifier in the system, and then they are counted in a digital counter. Now the counter is fed with a fed with a timer which sets the counting time, and you can set this counting time as you wish, like a few seconds or 1 or 10 minutes. The counts are collected over the selected period of time. In both the experiments, you carry out the counting, and then in the counting statistics experiment, you take three sets of counts, and you take the average of it in order, because this is a statistical data collection in the statistical experiment, and the theory of that counting statistics is already written in your sheet, and I think you know about this much because you have drawn the curve, and then you have also taken the least square fitting, and then you have determined all the parameters. Again here, you when you are using the GM tube, you first measure the counts with respect to the voltage, applied voltage to the anode with respect to the cathode, and you determine the plateau region. You also should understand what is the meaning of the plateau region. Initially, when you apply very low voltage between the cathode and anode, the radiations which are entering, they ionize and the electrons are collected. But as you go on increasing the voltage, more and more number of electrons will get collected over the anode, and this is a linear kind of a region. However, what happens once you have reached a particular voltage, depending upon the geometry of the GM tube, those which are ionized, the electrons will all the electrons will be collected, and even by increasing the voltage, there is no extra charge collected on the anode, and therefore this becomes a flat region. So by variation of a little bit of the voltage, it does not change the count rate, and thus you get a flat period. And then after certain flat region, when you increase further the anode voltage, what you see is it sharply increases, the counts sharply start increasing. This is a breakdown region, and there is a avalanche breakdown. That means each electron which will be ejected will consecutively gain energy, get accelerated, and further ionize the other atomic argon atoms, and thus number of electrons will go on increasing, which are collected on the anode. And so this is a steep region. Now here you have to use the plateau region, because in plateau region, even if the voltage is varied or changed because of some reasons from the power supply, the count rate is not going to be affected, and therefore you have to first choose this plateau region and then work within this particular region. So this is the about the GM tube details, that minimum which you should know. Then there is second part in the GM tube, that is you add some quenching gas like ethanol. Now, what is the use of this? Actually, what happens is when the positive ions hit the cathode, that is the cylindrical metallic cathode, they eject the secondary electrons. Now, these secondary electrons otherwise will reach the anode and again form the signal. In order to avoid that, you use the quenching molecule. Now, these molecules have low ionization potentials, and therefore those electrons which are ejected, they will be again ionizing, and they will lose energy and they will not be collected. So, but however, there is a lifetime or a period of for which the GM tube will be remain operative, because this quenching gas will slowly get dissociated, and it will no more be active. Now, one third part which is also important is a known as a dead time or a paralysis time. Now, dead time is where there is a period for which all the electrons which are collected will be forming the space charge, and they will not be further collected. So you have to use a known amount of time period, uh, because the tube otherwise will be dead for this amount of period. So rather than getting any error, you keep a fixed value of the period of anode voltage, which wherein over that period you will not collect the counts. So there will not be any error. So this dead time which you set, or a paralysis time which you can set from the unit that you are using, that is the counter, is around a few microseconds. So over that period you control it, and then you will not get any error in the counting. So these are some of the minimum points for the instrument that you should understand, and you can answer whenever there is a question, but there is no limit to it, and you can, if you are interested, you can read more further, go into the details and get more information.